This is the ContextifyHub, our design solution to improve patient outcomes in neurocritical care.
At the onset of this project, we discovered a gap in existing clinical practices regarding ICP measurement. This affects more than 20,000 patients each year in the United States. In addition, we're also looking into the effects of so-called contextual factors. These are things like light, sound, and temperature levels in the neuro-ICU. These have been shown through anecdotal evidence and some limited studies to have an effect on patient outcomes, but really, clinicians are limited by a lack of available devices that can capture this critical data.
Acute or traumatic brain injuries can cause a life-threatening increase of pressure on the brain. That pressure needs to be relieved and monitored. One of the ways this is done is through an external ventricular drain, or EVD. Fluid flow from the brain is controlled by a stopcock, which either directs the flow to a drainage bag or to a pressure transducer that directly measures a patient's intracranial pressure.
When the stopcock is in any position, you get a number. You will always get a number, but the number's only accurate. The number only tells you about the ICP if the stopcock is in one of 4 positions. How do you know? Like if you walk out of the room, and as nurses, we've all done this. We've walked out of the room because it's really busy. And how do you know you left the stopcock in the correct position? Because you're still getting a number. And like that could be a huge safety issue. You're getting a number, but you might not get a number that tells you about the ICP.
Our solution includes the stopcock position sensor, or SPS, and our central hub. This allows clinicians to track stopcock position, light, sound, and temperature levels in the neuro-ICU, which enables the development of standard care protocols.
We tried to make the operation of our device as simple as possible. On-screen instructions guide you through calibration, in this case, turning the device on, calibrating off to patient, off to transducer, and finally off to drain. At this point, calibration is complete and you are directed to the recording screen where you see values for light, sound, and temperature, as well as the stopcock position. You'll note when we turn the stopcock here, that value will be updated both on the screen and logged to our data file, ready for machine learning.
It's natural for the nurses. This doesn't change any of the requirement for the nurses. It's just more accurate data with no additional work.
But what did take a lot of additional work was this project. This is the culmination of more than 24 housing revisions, 5 PCB revisions, 2,000 lines of code, 600 hours of dedicated work culminating in 1 clinical trial.
Every nurse that I have talked to, every intensive care doctor that I've talked to has said, oh my God, what a great idea. And they act like, why hasn't anybody done this yet? So the world's ready for this.